Greetings and welcome to Code Quickie. And today we're going to be looking at creating a streaming data pipeline for real-time dashboards, visual dashboards with cloud, Dataflow, and PubSub. So in big data and data science, we're going to hear about pipelines a lot. And the overview for a pipeline is basically how to deal with data as it moves through your application. Say, for example, you have a project, you have an IoT device, and say you have cameras, and it's constantly monitoring the building, any movements, any actions that take place, right? And say it's a regular work day in the morning, any movements, any actions that take place, and cameras are acting as IoT devices. They're sending their data to application, and application is trying to determine through its machine learning model whether certain people are trying to be there, whether they're intruders, whether people are in authorized locations, and trying to send alert management to the security team at the data center. Or you have IoT devices dealing with temperature sensors for various items and mechanisms and control factors in a factory, sending once again data to a central application to determine if temperature is exceeding what the normal is, right? And when you're dealing with that, right, there's variety, right? What type of sensor that we're sending, what type of device that we're using, what software is on the device, what programming language. All right, I would say framework programming languages is a bit, is a bit much, right, to say, but no pun intended. But right, there you go, with frameworks that the application is using to send out the data. Then there's the volume, how much data is it sending? Is it sending megabytes worth? Is it sending gigabytes worth? And can we scale? Can we scale? That's important. And another thing is the quality of our data. Does our data need to be transformed? Is our data coming up a bit late? Is it coming out of order? Is it latency, right? We need an API that deals with that, and we deal with that with PubSub, right? And we have pipelines, and we call each instance of getting data from a source into our application, we call it a pipeline, because that is a whole science in itself. There's so much factors that go into play that it's just not, that has to be called a pipeline so that we can actually focus on it, notice it, and understand it, and respect it for what it is, and understand its definition, right? And we'll start on that. When you have all these sources spitting out data and try to get them over to the application, what we want to do is we want to have an efficient way of getting our data in an optimum way possible with scaling, and we could do that through Cloud PubSub. Now, just to overview Cloud PubSub, we have publishers and subscriptions. That's what PubSub is all about. We have publishers, say an IoT device that is sending us data, right? Say about thermometer, or about, like I said, about cameras. It's sending us that data, however it come, whatever size it might be, and whatever quality it might be in, if it's in RAW or it's already in needed format. And we have our subscribers, say for example, it's hard to give an example, but just anything that's any subscriber would just need the description of any application that is trying to calculate and monitor the performance of the building, of the devices in the building. Well, and just one important thing about PubSub, when you're dealing with IoT data like this, you can't use PubSub alone, because PubSub only captures data. It can store it in itself for so long, but PubSub was not created to be BigQuery. And you're just going to hear about this again when you're using GCP platform. You're going to be using BigQuery, and PubSub isn't BigQuery, but you can't get everything done with PubSub. Right? You can get things done with BigQuery, but when you're dealing with something with IoT, PubSub is obviously the choice, right? And something needs to come in between that. Something needs to be able to get that data once it arrives in the application and get it to where it needs to go in the application, say BigQuery, and we do that using Cloud Dataflow. And then Cloud Dataflow is not really a framework in itself, right? We put Apache Beam on that. That's and there's obviously SDK. It's a framework when it deals with data, and people love using Python. There's also Java and Go SDKs that Apache Beam uses, and you put that on Cloud Dataflow, and there through Cloud Dataflow, now we could get our data over to BigQuery, which is ultimately important. So enough with the overview. With our the lab that we're going to be looking at today is that we're going to be looking at a stream of taxis. Say we have a taxi fleet and we want to monitor them in real time. We want to monitor the overall customer satisfaction. We want to monitor the amount of passengers we're picking up. We want to monitor the pickup, the drop off, and the meters. And we just want to see overall how our taxi fleet is doing. So let's go ahead and get started. So first things first, want to go ahead and do is head into the command line like so, right? And I just hopped right into command line, but if you need to access the command line, if you go ahead, just click activate Cloud Shell. I should call it Cloud Shell, not the command line. And that's what we're going to be doing. So we're going to go ahead, my test prompt, and we are going to first of all create a BigQuery data set for our data to end out. So we're going to use the command line, BigQuery, and every time you see that, at the end of it is at the end of it is REST API. You want to go ahead and use that. But before anything, I just remember I get all these errors that don't make sense. When you get errors that don't make sense, you want to make sure that you use the gcloud config set project and to the project that you are in. Here, mine is GCP data certs, right? Want to go ahead and set that up like so. Want to use BQ make taxi rides, go ahead and make your data set like so. And then you want to go ahead and make the table. What you really need is this T flag right here if you want to make a regular table, but we need this schema, right? If you take a look at the schema a little bit, right, you can see the ride ID, you can see the latitude, the longitude, right? So the mapping that our sensor that is coming out of Dataflow, right, because it goes into Apache Beam. Apache Beam is here what does the transformations. The data that's coming out of Dataflow into Bigtable, into BigQuery, right? It needs this schema for, it needs Dataflow, it needs a table with this schema in order for things to be set correctly. Because when we code this out with Apache Beam, that Apache Beam Python SDK, we are looking for endpoints for this schema for our data to go through like this. So we're gonna go ahead and make our table like so. If no one understood what I said, you're going to see it later more visually. And next thing you want to go ahead and do is you want to make a cloud bucket. Just want to make it through the command line. In previous videos, I showed you how to make it through the UI. It's going to go ahead and one already exists, right? So that is okay, but that is how you go ahead. You just util md Google storage URL, and then the name of the file system. Name of the storage bucket has to be globally unique, and I usually like to take the project ID as practice, so I don't have to spend hours looking for a globally unique name and make a service that does that for me, right? So next thing we want to go ahead and do is finally leave Cloud Console. I want to head over to Dataflow, right? And we want to go ahead, create a job for a template like so. Going to name it Streaming Taxi Pipeline. And this is where the focus, this is where the foundation of this project starts to come in, right? Public topic to BigQuery, go grab our public topic, right? This is Apache Beam. Python code going on over here. We don't want to take a look at, we just want to see how it works. And we want to see what concerning pipelines, we want to see how it works concerning getting our data out of those IoT devices into our table. We want to see how it works real time. And go ahead and get our output table, right? Have Dataflow send that Apache Beam data into BigQuery output table and the temp location, right? Because we're probably going to be dealing with gigabytes of data, right? That Apache Beam is going to filter out is, and task is going to go to, right, the storage bucket that we made. And we're going to go ahead and run the job like so. Right now we're running the job. Now you might have an issue, right, when it comes to dealing with data flow, and you might get an error, and we might talk about one of the errors right here. Let's go over to this job that failed, and it's going to say something along the lines of Dataflow API is not enabled. So whenever you're on Google Cloud Platform and you get this error, Dataflow API is not enabled, this is never the case, right? This is just one of the things Google's trying to throw you off, because if you think about it, it's always enabled before you can get to the Dataflow UI, before you can do anything, before you get errors and say you can't create the project, right? You're going to want to enable the API first. This is something that you're just going to know. You're not going to get to this page right before you're going to get to enable this page. This is something Google does to throw you off. And like I said, I'm just going to explain later how Google wants your money. That's why you see this free trial status here with a US dollar side. This is all about money, but the real problem is the service account. So anytime you really have issues with GCP, it's either the code, you're missing your credentials in your code, or it's a service account issue that doesn't have the right roles. So let's go head over to consoledevelopers.google.com. Right, and then let's head over to I am an admin, and just want to show, right, the service accounts, and we can see here that we have some service accounts ready to go. Compute Engine, default service account, Google API service agent. All right, and this is going to say, hey, the service account you need when you want to do anything with GCP, especially through APIs, because that's the only way you can do things. However, this is the account responsible. You delete this account and things start to go haywire, even though they try to tell you, all right, even though they try to tell you, this is the account, this is the really important account, this allows things, this is where the action takes place, right? You really doesn't need this account to get things done, right? It doesn't really, I don't think it really needs this account for anything. This is the account you kind of want to touch, right? So when you're out here in dealing with service accounts, you want to try not to remove anything. I know it's a security issue. What you want to do is you want to take a picture of what you last saw and then start to remove the roles one by one. Then instead to try and go ahead and delete the whole service account, because the API might need it. The API might need it, and now you even know the name. These names are not easy to remember. They're very similar, but they'll throw you off, and you're going to be very, very stuck. You can hope these numbers are the same. You can take a close look. I ain't taking a close look, but all I know is that items like these, like Dataproc, Compute Engine, all right, we didn't even use a Compute Engine that's VMs, but they do get made. You don't want to touch them. If you think there's a security issue, you just want to go ahead and remove the you just want to move the roles like so. So one of our biggest issues is with the Dataflow service account, and this is where Google takes your money. Usually when a Dataflow service is created, it starts with a cloud Dataflow service agent. We see the description, and you don't get to create and manage Dataflow jobs. So what you want to do is you want to add a Dataflow admin so that service will go ahead and create those jobs that you needed, so that when your taxi pipeline runs, right, it runs perfectly with no issues, and you get a little warning that says quota, but hey, I'm still running. Instead, we can't run because your service account has a problem because Google doesn't want to initialize it. So basically what's happening here is that you're doing the steps that Google's telling you, but obviously it's backdoor. Obviously, Google's being very sneaky about it, but you just always want to know that it's something with your service account and your roles, that each service account is responsible for your projects in your that your projects and the API in those projects that the service accounts are going through to get things done. All right, they're having issues, and Google keeps it like this so that you can give them a call, ask them to help you fix the issue, and then you pay them for this. But with a little bit of intuition and really trying to open your mind and not being narrow-minded about the trickery, right, you can just see through the mess that, all right, I just need to add some roles here, and 100% of the time, the API starts to work like it should, right? Right, that's the service accounts actually are a very important security feature to Google Cloud Platform on their side, on the cloud side, and we that's why you have service accounts. So now there's just like a double-edged sword right there, where we're also get affected, right? And I think it's just one thing is trickery, but another thing is Google Cloud just wants you to really understand how important these service accounts are, because they're actually important. All right, so we're going to go ahead and do refresh the page here. We have taxi rides, and then we have real time, and we'll look at a preview here, and then we have some data, right? And now what we want to go ahead and do is just take this taxi data, right? And we want to look at all the drop offs. So I just analyze our data, and we can show you how this is real time, right? So we can see on September 28th, 7 a.m. and drop off. There's a meter reading, and then if we run this again, we can see that the application is actually working in real time. All right, so this is very nice. This is very beautiful. So now you can see real time, and then we could go take this into further analysis. We could go ahead and send this into a machine learning model, right? If we just want to ask where our taxis are making the most money, right? We could use latitude, longitude, get a little join going, so we could put titles to the places that taxi drivers are picking them up or dropping them off at, and we can adjust our business needs also. And but I say we don't want to get too technical, right? Because not everyone in the company has a master's in data science, right? So we want to visualize, or you just don't like looking at SQL anymore, working with SQL and square tables, right? So we could go over to what we have known as Data Studio, how you get there, explore data, and explore with Data Studio. Now, first, the interface is actually rough, right? You kind of get thrown off, but once you use it more and more, it becomes very straightforward. I'm actually looking at this for the second time, and I just know how to go about doing this, right? So our dimensions is right here, right? IDs, you could see that's basically our X columns, and then the metric is the metric count and wants to go by. We really don't want to go. So it like just sees for every single one, it just sees one instance. We could change up the metric to be the sum, and I'll just show you a better way with the passenger count. So now the passenger count, right? How many passengers that we get from 10 items. We have 10 different rides we're looking at. How many of those rides had one passenger? How many of those rides had 3, 5, and 2? And now say we want to add another metric. How much did they pay? What was the average? What was the average? We don't want to sum. We just want to average. We want to see how much on average did people pay. So for one, right, the record count was, the average was $10. So people who had taxi rides, they had average of $10. People who had 3 passengers, right, their average was $12. People who had 5 passengers, right, that weighed 39, average of 2. That's like, and unfortunately, this data, right, it doesn't represent things very well. All we can go ahead and do is increase our data set, our table, right? Explore the data again. Let's cancel this out. Head over to our column chart, look at our x-axis, which we want it to be passenger count one more time. And then over here, you want to change the style. I want to look at 100 here. Well, that's not going to be the limit when you have more data, right? 1, 2, 3, 4, 5, 6, right? Our metric instead of that is going to be meter reading, right? We want to look at the average instead of the sum. Right, and then we could see again, right? So we could have a better reading. So the amount of trips that had 2 passengers was 16, and the average that 2 people had to pay was $28. For we have 69 trips for the passengers that had only 1 passenger, and the average amount was $14. Right? And then with 4 passengers, the average was $14, and then with 6, the average was 11, right? So we can see from this graph that we might have a little issue. We're saying we have 24 times a driver had 6 passengers, but they're paying about the same amount for some reason. People with 2 passengers, right? They are paying more, and it might be reasonable. It might be just a couple. They are going to other side of town to go for a night out. Well, it's a family of 6. They are probably trying to go to the grocery store and can't leave anyone at home, and that's why they go as 6, right? So like I said, right now however, we want to see this update in real time. So we're going to go ahead, use this query, and use this advanced little SQL. We don't want to get into it. We just want to just show you how we can use Data Studio to show those who don't have a master's degree in data science, right? How they could look at what's going on with their taxi fleet real time. Go ahead over to column. And now we're going to use this table and fill those values out like so, right? So the chart type that we have here, chart column type dimension is going to be dashboard sort, right? That's going to be our little x-axis right here. Drill down, turn on that drill down, just a little defaults. And then we want to go ahead and add a minute in there. No, a little dimension that we want to go ahead and add. Now our metric, want to look at total rides. Want to look at how many rides that there are. Oops, we go in the right field. It looks like it did. All right. Then we want to see the total amount of revenue that's being made, and then we want to see the total passengers on each. All right, and then we want to sort by ascending. Want to sort ahead by the dashboard sort. The dashboard sort is really like a timestamp. Want to get into the logic of that, but we can see that, all right, we have our chart where we see the total rides associated with this timestamp, the revenue made, and then the passengers on that trip. Want to see the total rides, revenue made with the passengers for this. And we want to go ahead, refresh. And unfortunately, you want to go ahead and hit the save button. I'm not too sure if it's saved. It's the save button that's actually allowing this to update real time. It shouldn't be, but just for good luck, you want to go ahead and hit that save button. We allow this data chart to update real time. And we should go ahead I refresh the data. Right, we are starting to get different data, right? So now we're starting to look at some of our revenue here coming up in the hundreds, right? The passengers for that ride was 4, all right, that total revenue for the trip. The passengers were 8, the total revenue for that driver was $62, right? Passengers that that driver had and the total revenue that that driver is making, total, right? The total rides, total passengers, how much that driver made in that certain period of time, right? So this is good. These drivers are doing well, and these other drivers not so well. And then trying to explain that with SQL, it's just see how much easier it is to realize that from SQL, right? We're actually querying one table. We're querying one table, right? We're creating actually a query. We're querying a query, and then high-level SQL functions, right? Just to see what's going on. But now with Data Studio, you can simply see which drivers are doing well and which drivers are not doing so well. Not very hard to try and see that from the table, right? You can immediately see that better, right? So that's how we can go ahead and use Dataflow, and we can use PubSub, and we can use Data Studio in order to make meaningful insights with our real-time data. So thank you for watching. Please like, share, and subscribe. And please leave in the comments anything, any assistance. I always love to give out personal assistance and reach out with my crowd, work with my crowd. Definitely love to see you advance in the data science industry, as it is a great industry. It is growing, especially with machine learning, and there's a lot of features yet to come. So once again, please like, share, and subscribe. Thanks for watching.